Hey, Wendy. All right, good morning and welcome back. I hope you guys are doing well and staying safe. I'm looking for John, and that's it actually today, just John. If you're out there, just unmute yourself and throw it in the chat, something just to let me know you're here. All right. So welcome back. Hope you guys are doing well. Let's go through a quick little update for COVID, see where we're at for today. COVID update. There are 5,434 cases of COVID in our area. Additionally, we have, let's see, 183 hospitalization rates. We have 28 ICU patients that are in the county from COVID. And death rate to death, there's 248 just in our county for COVID as well. The numbers, a good sign is the numbers for yesterday, which was Monday's data, is lower than what it's been for Mondays. So when I compare the data, you can see like what happened, the trend. You can see the beginning of the school year to the colder winter, fall, winter. But anyways, zooming in on the Monday, there's 207, and usually that's typically higher for Monday. So Sunday was 173, Monday was 207. So hopefully Tuesday, Wednesday, Thursday, Friday stays low like that, and hopefully the vaccines will start to kick in, and hopefully this will all go away. It's craziness going on here. We could check that out. Still, COVID's a huge risk and a factor for our communities. But you can check that out if you'd like to. All right, does anybody have any problems, questions, concerns they want to talk about before we jumpstart for today's class? All right, so before I jump into this, I do want to just let you guys know the exit passes are the main source of my grading for the 5 weeks and really for everything in general in this class. So there's no test besides the benchmarks. I'm not doing unit tests because they're so easy to cheat on. My little snapshots of my exit passes is how I am grading for the year. So that and my guided notes, that just allows me to see if you guys are kind of doing your work and not just cheating on those exit passes at the end. So it's my way to back myself up to see if you guys are doing stuff that goes with this class as well. So please, please, please do the exit passes. I am going to continue to add exit passes at the end of every topic, and those exit passes, they're going to be titled, I'm going to start titling them exit pass. Those exit passes we do not do in class, but those are something to do following the end of class. So I will start to give you some more time in class to do them. Warm-ups are not part of the grade because I go over those. The examples are not part of the grade because I go over those as well. So please complete those exit passes. All right, for today's class, we're going to start off. Let's go through the agenda for today. Scrolling a lot today. Welcome back Wednesday. The quote of the week comes from Brad Paisley. Tomorrow's the first blank page of a 365-page book. Write a good one. Daily agenda for today, the 6th of January, 2021. So day one. We are continuing on with chemical bonding or balancing chemical reactions. We'll start off with a warm-up. We have a flick again, and then we have like 4 examples we'll put in our guide notes, or 4 total examples. I think you have one more. We'll analyze more examples, and then we have the exit pass that you should be able to complete as well. So that exit pass you should be able to complete at the duration end of the class for today. Please open up the warm-up that's above. It says 1/6/21, so for today, 1/6/21. If you click on that, you'll notice that the title on Google Forms is actually a different date. But this is the one I do want you to complete. So the title on the classroom page says warm-up 1/6/21. Click on that. On the Google Forms, it's 1/5/21. The dates don't really coincide, but this is the one I want you to do for today. So please take 10 minutes to complete the warm-up. You can see the first question. Make sure you have the right one. There are 5 questions. Some of these do not have the right bubbled-in answers, but I just want you to note the right answers. We'll go over this after 10 minutes. So let's go at 12 o'clock. We'll review this. Please work on this from now till 12 o'clock. I will put some work up here of my work to how to do this in case you get stuck. Please do work on this from now till 12 o'clock. We'll back Wednesday. No, you do not have to turn in the previous warm-ups. Warm-ups are not graded at this time. Okay, hopefully enough time to get through those 5 questions. Here we go. Let's check them out. Question number 1, it says, what is the percent by mass of oxygen in magnesium oxide? In the teal or the light green over to the left, I did put the work for that. So you could see my work, or if you drew a brain fart on how to do this, you could check this out. It's the last page of the reference table. You can see this. And on the last page, tab there now, the formula is percent composition. It's going to be part over whole times 100. So part over whole times 100. I worked it on out. Hopefully you remember there's no mass in there. There's no mass initially, but if you did the GFM, you could solve for this answer. Please put the answer in the chat. Once you solve for it, please put the best answer for number 1. So after you do it, solve for it, please let me know what the best answer is. Thank you, Faith. Thank you, Emma. Thanks, Asim. Thanks, Tristan, Zen. Thanks, Ruben, Alex. Yeah, so a lot of us, hopefully you followed my work here. After you went through the process, you should have got choice B as the right answer for that response. So checking on out, part in the situation was going to be percent of oxygen. So 16 goes in the part. The whole is a whole GFM of Mg and O. So the whole thing goes right there, 40.3. Solve for it, multiply by 100, you should get 40%, or 39 point something percent. So 40% for the first one. Next up, question number 2. Question number 2 says, if the equation is balanced properly, both sides of the equation must have the same number of what? Please put the answer in the chat for number 2. Both sides of the equations. Good. Good. Okay. All right. All right. So a lot of A's and some D's, a lot of D's. So A and D looks like it's pinpoint to be the right answer. One of them is. Coefficients would be like that number out in front of like H2O. If there's a coefficient on one side, the coefficients must be the same. No, we know that the coefficients could vary from the reactant to the product side. So coefficients, we know it's not the right answer. Molecules, that's a molecule. H2O is a molecule. And the moles of a molecule is the coefficients. So that really is the same thing as that. I guess it's the same thing as that too. The thing that must be balanced on both sides, what I'm doing down here, you're trying to balance out, if it said moles of atoms, then that'd be a good answer. But it says moles of molecules, that's not gonna be the right answer for that reason. So the moles of atoms must be equal on both sides. The balancing equation, both the moles of the atoms must be equal on both sides. So that was tricky. Moles of atoms, so know the difference between a molecule. A molecule is like H2O, or a molecule of sugar or glucose. Molecules don't have to be the same. Atoms have to be the same. So number 2, the best answer was A. Number 3, what's the mole-to-mole ratio between nitrogen gas and hydrogen gas? Let me check this out first before we get too far on this one. So nitrogen gas and hydrogen gas. So be aware of what gases are. Gases are going to be diatomic molecules. So if something forms with itself or bonds with itself, it's going to have the property of being a gas, such as N2, which is going to equal nitrogen gas. O2 would be oxygen gas. This H2, H bond with itself is hydrogen gas. It's a diatomic molecule. Several more. Let's see. Cl2, chlorine gas. Get fluorine gas. Those are the main ones. Br2 would be bromine gas. But those are really the main ones. If there's something bonded with themselves, it's going to be called a gas, not just an atom. So N2 is nitrogen gas. H2 is hydrogen gas. It wants to know the ratio between N2 and H2. What's the ratio in that one? Please put the answer in the chat. Number 3. Thanks, Faith. Kim, good. Zinth, good. Ratio. What's the moles of the molecules for these? So a little bit more information. What's the moles? How many moles of N2 are there? How many moles of H2 are there? So the moles is going to be a 1 to 3 ratio. It's a 1 to 3 ratio for the number of moles of those gases. Most people put that in there. Cool. So it's a 1 to 3 ratio. I kind of talked about that a little bit yesterday. Talked about the ratio. The ratio of the coefficients is whatever. This is 1 to 3 to 2. All right, so number 3, best answer is B. Number 4, checking on out, says, what's the total number of moles of oxygen in 1 mole of N2O3? And 1 mole of N2O3. Please put the answer in the chat. Good. 1 mole of N2O3, there's going to be 3 moles of oxygen. Bob, you put 3 moles. Thank you, guys. 3 moles of oxygen. And the last question, talking about a balancing equation. 3 was B. 1 to 3. And the last question, here we go. It says, which molecule represents X? Given the equation, which molecule represents X? So I was starting to balance this equation. As you balance the equation, you can start to see what's going to happen here. What's going to be left off here. Down. All right, for this last one, you're welcome, John. I went through it, balanced it. I put a line down the middle. Once I put the line down the middle, I could figure out what's on the reactant side and what's on the product side. The product side, I had 2 moles of carbon, 6 of hydrogen, and 2 of chlorine. And then I went in the reactant side, I compared the exact same values in this exact same order to the reactant side. So product side to the right, reactant to the left. Chlorines, they're balanced out. They're good to go. There's not going to be any more chlorines on the other side, but there has to be some more carbon and hydrogen. So we're definitely missing some carbon and hydrogen. How many? There's got to be carbons. There's got to be 2 more to make up, and there's got to be some hydrogens to the left, which are going to be 6. So if I have that molecule in for X, they're going to be balanced on out. So C2H6 would be the best answer for the last one. Does anybody have any questions on questions 1 through 5 on the warm-up for today? Thanks, Asim. Seems good. If you have questions, please feel free to ask. If at any time you are stuck, you're lost, you want more help, more one-on-one time, or you want some one-on-one time, at the end of class, I will be available, and you could ask whatever you need, address questions, or if you need me to go through a couple of exit pass questions with you, I can do that too. All right, so that clears off for our warm-up for today. Next up on the drawing board, we have a YouTube video. We watched one last time. This time we're going to watch another perspective on balancing chemical equations. Here we go.
Dave, let's learn how to balance equations. He knows a lot about the science stuff. Dave explains. When substances interact and chemistry occurs, we can describe the process using something called a chemical equation. For example, when sodium metal reacts with chlorine gas, you get sodium chloride, or table salt. The arrow here is what separates the reactants, the things that react, from the products, the things that you get. The arrow also shows the direction of the reaction. When you see a chemical reaction, it describes the substances involved, but if we want to be very accurate, we need to balance the equation so that there are the same number of atoms on both sides, because atoms won't just appear or disappear, they all have to be accounted for. For example, in order to make 1 molecule of sodium chloride, we need 1 sodium atom and 1 chlorine atom. But chlorine gas molecules have 2 atoms of chlorine each. So 1 molecule of chlorine gas will react with 2 sodium atoms to give 2 molecules of sodium chloride. We need to include coefficients before each substance to indicate how many of each we need to make the equation balanced. Let's make the distinction that these subscripts tell us how many atoms of a given element are in one molecule, whereas these coefficients tell us how many of that molecule there are. In the reaction where hydrogen gas and oxygen gas go to make water, we can see that the gases have 2 atoms each, and water has 2 hydrogen atoms and 1 oxygen atom. We will need to combine these substances in this ratio to make this equation balanced. Now there are the same number of hydrogen and oxygen atoms on both sides of the equation, even though they have rearranged their combinations. So if we have an unbalanced equation like this one that we need to balance, there's an easy way to do it. We will balance things one element at a time. If an element exists by itself, do that one last. Start with an element that is present in just one compound on each side. Let's do carbon first. On the left, there are 3 carbon atoms for every molecule of propane. And on the right, there is just 1 for every molecule of carbon dioxide. So according to the carbons, we are going to make 3 CO2s with every propane. Let's put a 3 there. Now the carbons are balanced. 3 carbon atoms on each side. Next, let's do hydrogen. There's 8 on the left and 2 on the right. That means we will make 4 waters with every propane. Now hydrogen is balanced, 8 on each side. Last is oxygen. On the right, there's 6 from CO2 and 4 from water, for a total of 10. That means we will need 5 molecules of O2 to get 10 oxygen atoms on the left side. Now the equation is balanced. There is the same number of each type of atom on both sides, showing us the correct ratio in which these molecules will have to react. These coefficients are going to be very important as we move forward, as we will have to be able to balance equations to make predictions about chemistry. Let's check comprehension.
Feel free to try those out in your own time. I'm not going to give you time to work on those now. I'd rather do some live examples with you guys. All right, so hopefully that video gave you a little bit more knowledge on balancing chemical equations. There's a flick. Let's open up our guided notes. Please open up your guided notes for chemical bonding. Please take a minute to figure out where we left off. We're on topic 8, balancing chemical equations, reactions, balancing chemical equations or reactions. So please scroll on down to the page. I think it's 22, maybe 23 on your page. Hopefully you guys are staying up to date with your guided notes. Again, this is how I'm grading you on seeing if you're actually paying attention and doing what's expected here. So last time we talked about balancing chemical equations. So today's gonna be like a math class again. Topic 8, we said the reactants must be equal to the products. They both have to be balanced out. It's a shift back and forth to find a balance. And balancing equations, the first step you have to do is find your metals and balance the metals. Step number 2 would be balance the nonmetals, the negative ions, except for H and O. And then the last thing is going to be balance your H and O. So the steps are super simple. Balance metals, balance nonmetals, balance the H and O. If you follow that, a lot of times the H and O fall right into place. Last class, we analyzed, I think, 3 examples. Yep, 3 examples. I might have went quick on the last one, but we did get that one done as well. Today, we'll put one more example in our guided notes, and then we'll analyze 5 examples on the Google Sheets, Google Worksheets or forms, and then you can work on the exit pass. So the sooner we get through that, the sooner you guys will be able to work on the exit pass. All right. Hopefully enough time to find out where we are. Example 3 done. Example number 4, put one more in our note packet. I'm gonna do the same thing I did last time. I add a cell here. So scroll right down below example number 3. I'm gonna go to insert table, and then I'm gonna add 1 cell. Insert table, just 1 cell. I'm gonna call this example number 3, number 4. Jumping ahead. Example number 4. I'm going to fill it in with a color. Let's go yellow. You don't have to color code it. It's totally fine. And this example, we do dash line 2 times shift dash line. It's going to be C8, H16 plus O2 yields H2O. Again, to get that subscript value, it's control, comma. To bring it back on up, it's control, comma. H2O plus CO2. So I'll blow this up, give you guys a chance to copy this down. Make sure it's correct. I'll check my end, make sure mine's correct as well. Okay, so again, example number 4 is going to be C8H16 plus O2 yields H2O plus CO2. So that's the formula we're going to be trying to balance. The question of the Regents would say, balance the chemical equation. Balance it. Or it might say, what's the sum of all the coefficients? Definitely anticipate to see at least one question on the Regents on balancing. And you can anticipate to see one on the benchmark for quarter 2 on balancing as well. All right. So once you have that formula, it's correct. I'm going to highlight it. I'm going to copy and put it into my drawing pad. Does anybody need more time before I get into that? All right, so I'm gonna copy it, Control C, I'm gonna paste it back on in. I'm gonna go to Insert, Drawing, New. I'm gonna paste it on my drawing board, Control V. Oh, didn't work out there. What happened? There it is. Control C. Hopefully this copies. There it is. So hopefully it pastes on in. A little glitch the first time. All right, so that's the one we're trying to balance out here. I guess I'll guide you through one more example, then the next ones I'll have you guys help me out with. So here we go, the chemical equation. The first thing I would do to balance this chemical equation is put a line right down the middle. So a line that divides my reactants and my product side of the equation. So there's my line, just got a little segment, change the color so it pops a little bit more. You don't have to. Make it pop. So again, balancing equations, the reactant side has to equal the product side. Now I'm going to take a text box, the T, click on that T, and I'm going to figure out how many of each of the atoms are present on the reactant side. I'm going to say, hey, how many carbons are on the reactant side? And you would tell me that there are 8 carbons. Next, I'd go through the next element. I'd go right in that order as you go across the reactant side. I go H, how many hydrogens are on the reactant side? There are 16. And then I'd ask how many oxygens there are as well. And you tell me there's 2. I think you could do that. Should be able to figure out how many of each of the atoms are present on the reactant side. You should be able to do the same thing for the product side. Figure out how many of each of the atoms are present there as well. You should keep them in the exact same order from carbon to H and O. If it doesn't go in that order, just leave them in that order. It makes it easier to interpret. So you could copy and paste that text box and bring it on over, or you could just add another text box. I don't care what you do. I'm going to copy and paste it and just drag it on over with my arrows on my keypad. Obviously, these numbers are not going to be the same, so I'll just get rid of the numbers. So again, the atoms are in the same order, so when I go across, I can compare them pretty easily. Now I would ask you how many carbons are on the right side or the product side, and you would tell me that there is 1 carbon. I'd ask about hydrogens, and you tell me that there are 2 H's. And oxygens, there's 1 with H2O plus 2 more for CO2. So 3. So some people from last class were stubborn. They didn't want to keep them in the same order, and then they couldn't figure out why they couldn't match them up correctly. The why do I keep them in the same order? It's just so you could go right from side to side and figure out what they are. If you don't put them in that order, it's not the end of the world, but it's going to be a little bit more tricky. Say, oh, carbon's here, carbon's here. When you have more complex reactions, it's tougher to really see those. It makes more room for error, I think. All right, so step number 1 would be to balance the metals. Hopefully you have a reference table handy. Balance your metals. Checking out the reference table, there are no metals in this equation. Step number 2 would be balance the nonmetals, except for H and O. So find your nonmetals, except for H and O. Oh, that's easy. So you have to balance carbon first. H and O are last. We'll do those last. So here we go. We have to balance the carbon. There's 8 on the left. There's 1 on the right. I can't change this to a 1. You can't just say, oh, there you go, it's balanced. No, you can't do that. The only thing you could add is a coefficient where that dashed line is, that little underscore line is. So you could add a coefficient, a big number, out in front. That's the only thing you can do. You can't change the subscript value. Yeah, so to make it 8, you need 8 on the right. You got to add a coefficient of 8 right there. When you throw a coefficient into the equation, what happens? Changes carbon to 8, but it also changes oxygen to 8 times 2. So that's going to change that as well. So carbon's now going to be 8, good, but oxygen is going to be 16 plus, we have 1 more hanging out over there too. 16 plus 1 gives us 17. So that number right there, oxygen, is going to be changed too. So we have 17 oxygens. Okay, step 1, balance the metals, none there. Step 2 would be balance the nonmetals, except for H and O. So that's carbon, that's balanced. Step 3, balance your H and O. So this one's like, I think the most difficult example that I gave you guys. You can see how I progressed from easy to more difficult. I did that intentionally. So now we have to figure out how the heck to balance the H and the O. So I would start off, whatever, it doesn't make a difference where you start. I have 16 H's and I have 2 H's on the right. This has got to get balanced somehow, so we might as well balance the H. How do you balance it? I need 16 on both the sides. There's no H here. There has to be an H here. So what times 2 gives you 16? It's got to be an 8. 8 times 2 is 16. Do not forget to distribute the coefficient. There's 16 H's, but there's also a different number of oxygens now as well. So let's change it on up below. Don't forget to go back and forth, change it. I like a paper and pencil so you can really go through all of it and cross it out. You can draw it, but what are you going to do? So H's are 16, but oxygen are changed as well. We have 8 and plus your 16. We have 24 oxygens. And then the last one, we have oxygen. We have to balance that on out. There is 2 oxygen to the left. We have 24 to the right. Balance them on out. There's no oxygen in the first part of the reactant. The second part has O2. I want 24 over here. What times 2 gives you 24? 12 times 2 gives you 24. Distribute that. So this can now change to 24. This equation is balanced. Oxygens are equal. Oxygens are equal. I'm sorry, carbons are equal. Hydrogens are equal. Oxygens are equal. That is a balanced chemical equation. The coefficients in this situation would be a 1, 12, 8, 8. 1, 12, 8, 8 are the coefficients for that one. Does anybody have any questions on doing that? Okay, last 5 examples. I'm going to have you guys help me out instead of me talking the whole time. I'll guide you a little bit if you need to, or if you want to actually teach the class how to do it, you're more than welcome to do that as well. So whatever assistance you need, I will help you with. If you don't need any, you can take it all yourself. Oh, I don't know why it worked that time. So I used my Zoom annotate and it still worked out, so I'm happy. So there's the coefficients, 1, 12, 8, 8. Someone asked, why did you put an 8 for H2O when you wanted to balance the C? Let's see if it lets me do this. All right, so we already balanced the C at first. I don't know how to explain this without doing it all over again. But we already balanced the C first, so the initial equation was, none of the stuff was here. So if you already got this down, you understand it. Zoom out, zone out for a second. No, you sure? I can go through the example again. I don't care. Yeah, that was the second thing I balanced. So that's why. So the carbon wasn't originally balanced. So I had 8 here, I had 1 here. I balanced that, I put an 8 here. Once I did that, it was 8 carbons. I changed the carbon. And then 16, 8 times 2 is 16 plus 1 gave us 17 oxygens. Hydrogen originally had 2. Let me fix these numbers back at the end. So the next step, so I think this is where you're probably talking about. Why did I put an 8 in front of the H2O? The second thing I had to balance was the H. So I balanced the H next. I chose to balance the H next. I was trying to figure out how to get to 16. And if I put an 8 in front of the H2O, it's going to be 8 times 2. That would give me 16. So that was my logic and why I put an 8 there. But I also changed my oxygen from 8, because I distributed, plus your 16, which would equal 24. Last thing, I had to balance my O, and I said 12 times 2 is 24. I think you probably already got that, though. All right, so coefficients. You could put a 1 in front of that. I encourage you to put a 1 in front of the blank ones, just because sometimes they're going to say, what's the sum of all your coefficients? A lot of times, if students don't have a number in front of it, they forget there's a 1. There is 1 mole of C8H16 because it's represented by the symbols. If there was none of them, there'd be nothing there. There's 1 mole for C8H16. All right, once you're done with that, you could close on out for your guided notes. We're done with the guided notes. And we have like 34 minutes to go through at least 5 more examples. So we'll go with our guided notes. Once you're done with that, please scroll up to your stream, your Google Stream. And we're going through this assignment that Jeffrey Brown posted, a new assignment. Examples balancing chemical equations. Please click on that. There's 5 questions that we will do together. Bunch of snowmen on here, snow ladies. There's 5 questions, and we'll do this together. So hopefully with those 4 examples, you have enough practice. I think Kai helped me last time. Yeah, she did. So someone else, could you please help me out? And let's try to do this. I'm not going to throw you the wolves or throw you the snowmen. I'll help you out with these examples. If you need it, if you want to teach the class how to do it, that's totally fine as well. So in the meanwhile, while I edit this, hopefully somebody grabs the courage to help me out, because the sooner we get done with this, the sooner you guys are out of here. Do I have any volunteers? Any friends that want to help me out with an example? Say, hey, Mr. Brown, I think if I engaged with you right now, talk to you right now, I'll understand it. Maybe. Maybe you're a little shy. Mike, how we doing?
Hi, Mr. Brown.
Hey, what's going on, Michael? How we doing?
I'm doing well. How about you?
Not too bad, thank you. How do you feel about this?
I'm not the best at this subject.
Oh, it's all right. We'll get there. I'm gonna go through some questions and hopefully you could just give me some answers here. This you could do on a separate piece of paper if you guys want to, or you could follow along with your classmate. Hopefully you could answer the questions as I pose them to Michael. But thank you for answering, Michael. All right, Michael. So we're gonna start off by balance this equation. I'm putting a line down the middle from my reactant to my product side. I already did that. And now I'm gonna figure out how many atoms are on the reactant side. So how many carbons are on the left side?
3,
3. How many hydrogens?
8,
And oxygen?
2.
2. That's easy. No questions with that, I'm sure. Now I'm going to keep them in the exact same order. Carbon, hydrogen, and oxygen. And now I'm going to figure out how many are on the product side. So how many carbons are on the right side?
1,
1. H?
2,
2 and O.
3.
Okay, step number 1 for balancing chemical equations. Balance my metals. Do I have any metals here?
No.
No. So he has a reference table in front of him. Hopefully he knows there's no metals. Step number 2 is to balance my non-metals except for H and O. What do you want to balance first?
Carbon.
We're going to balance carbon first because that's step number 2, rule number 2. Rule 2. How you going to balance carbon?
We added 2 to the right side.
All right, so if I add a 2 to the right, let's check it out. Add a 2 to the right. It's going to change carbon to how many do we have now?
Oh, so 3. So 3.
Let's check out 3. So we're going to have 3, a coefficient of 3. It's okay to try it out, use a pencil, make a mistake, learn from it. Now we have 3 carbons. How many oxygens do we have?
If we add 3, so multiply, right? So 6. And then
6.
plus the 1, so 7.
7. So he knows he got to multiply 3 times 2 is 6 plus that 1. Now we have 7 oxygens. All right, so carbon balanced. What do you want to balance next?
Can we balance the oxygen?
Well, you could if you want to. It's up to you.
So
So you want?
Oh wait, not yet.
It's up to you. You can do either one. You try them.
Can we add 4 to the hydrogen on the right side?
All right, so he switched it up. He's thinking about different logic here. Probably thinking about common terms, which is fine. He said put a 4 to the right for H2O. If we do that, how many H's do we have?
8.
8. How many oxygens do we have?
And so 11.
All right, so we have 4 O's plus your 3 times 2.
Oh, so 10.
10. So we have 10 oxygens. What's your next move?
And now we balance the oxygen. So we would add 5 to the oxygen on the side.
5 to the O2, oxygen gas. 5 times 2 gives us 10. What's your next move?
And then add a 1 to the far left.
Sure, you could add 1 there. Thank you. Nice job. We are balanced. We have carbons balanced, not too bad. Hydrogen balance, and we have oxygen. They're all balanced. So you could see how you can compare them pretty easily when they're on the same line. So that is a balanced chemical equation. Thanks again, Michael. So 1, 5, 4, 3, balanced equation. 1, 5, 4, 3. When the equation is completely balanced using the smallest numbers, the coefficient of O2 has to be 5. 5 is the best answer. 1 is A. Any questions for myself or Michael? Yeah, Joey, go to the bathroom. It's all right. You guys don't have to ask to go to the bathroom. So, can't really see you guys, so. But thanks for asking. Oh, Frank's got to go to the bathroom too. It's kind of, nah, this is weird. Joey and Frank are going to the bathroom at the same time. They both asked to go to the bathroom. I usually let one person out at a time, but virtual world's different. Frank, you go to the bathroom too. All right, question number 2 says when the equation AL plus O2 yields Al2O3 is correctly balanced using smallest whole numbers, the sum of the coefficients will be. All right, so I'm gonna just get rid of some space here of some text so I can write on here. All right, let's try this one on out. Bellman. How's Bellman doing today?
Good afternoon.
Good afternoon, Bellman. What's going on? Anything good?
Nothing much, just the usual, you know.
Loving chem class, eh?
Mm-hmm.
Bellman, what makes you you?
Uh,
What's that cool
my
fact about you?
personality, I guess.
Yeah? Are you in
Yeah.
like any band, orchestra, choir?
No,
Nah? Do you do any sports?
I
Any
play
sports?
soccer.
Oh yeah. Oh, sorry about that. This year it stinks.
Right.
Lost a whole season of athletics. Whole year maybe. Looking that way. I'll tell you what though, the baseball and the softball field at Proctor really nice. So maybe next year, maybe this year. I don't know. But that field does look good. Do you have any siblings?
Yeah, I have a younger brother and sister.
Nice. So you okay. That's cool. Do you want to teach the classes or you want me to guide you through this?
I'm not really the best with this, so
We'll get
can
there.
like get together.
Yeah, we'll do it together. That's fine. Where's my reactants?
Um,
Left or right? Reactants.
in the right.
That's my products. So products are to the right,
Oh,
reactants to the left. So it's going to always be reactants yield a product. Whatever the reactant's mass is going to be equal to the product's mass. So we're trying to balance this equation. I put a line down the middle so you could separate them. I guess I color code them too. All right, Bellman, here we go. How many ALs are to the left?
1,
1. Bellman, how many oxygens are on the reactant side?
2,
2. So you know where they are. Let's go to the product side. How many ALs are on the product side?
2,
Oxygen?
3.
3. All right, this would say balance the chemical equation. Step 1 would be balance the metals. Do we have any metals here?
I think aluminum is a metal.
Aluminum's to the left of the staircase. That's a metal. Let's balance that guy. How are we going to balance aluminum?
Multiplied by 2
Okay. Where?
on the reactant side.
So we said put a coefficient of 2 on the reactant side. If I do that, there's going to be now 2 aluminums. Aluminum's balanced. Good to go. Now we got to balance the oxygen. I have a 3 on the right, a 2 on the left. Any ideas?
On the right, multiply it by 2, and on the left, multiply it by 3, so it's both 6.
Yeah, you got that. So you found a common term between 2 and 3. You figured out what worked out here. But that's going to change my aluminum too. So 2 times 2, this can give us 4 aluminums. And that 2 times 3 gives us 6 oxygens. And he also told me go back to the left and put a 3 in front. Thanks, Bellman. It's not too bad. 3 times 2 is 6.
Oh,
Does anybody have any?
no,
Oh, sorry. You're right.
you gotta change the aluminum to 4.
All right, so we're going to swap that on out. This is going to be a 4. So we're going to change aluminum to 4. Anything else?
No, I don't think so.
No. Does anybody have any questions for Bellman? It's your chance to ask Bellman anything. Thanks, Bellman. So the coefficients are 4, 3, 2. The ratio on the reactant side is 4 to 3. The product side, there's a coefficient of 2. All right, so 4, 3, 2. Hopefully, does anybody have any questions on this one before I clear it on out for myself? Nice talking to you, Bellman. I don't talk to you enough. 4, 3, 2. 4, 3, 2. All right, so the sum, the question is asking for the sum of the coefficients. So this one's not asking for a coefficient in front of AL or O2. It's asking for the sum. We all know sums adding them all together. 4 plus 3, 7 plus 2. Best answer is going to have to be 9. 9's the best answer. All right, so you add them all together. There's the sum of coefficients. Hold on to those coefficients, 4, 3, 2, because question number 3 is going to be very similar to that one. 4, 3, 2, 4, 3, 2. Throughout the board. Says when the equation AlO2 and AlO3. So this is the exact same formula. Coefficients are going to be exactly the same. 4, 3, 2. You could do this again, or you could hit up Bellman if you need help with that one. Who wants to know the coefficients for AL? AL's coefficient is going to have to be choice D, 4. So it's just worded a little bit differently. Number 4, 2 more to go. It says given the unbalanced equation, it wants to know the sum of all the coefficients. So if they were to give you a question like this on the Regents that it's not in the same line, typically they do, but sometimes like an exit passes and something like this, it might not be on the same line. If it's not in the same line, the first thing I would do is put it all on the same line. So I'm going to rewrite this equation out. So rewrite it out just so it's all together. Just give me a second to rewrite it. Cash money. All right, so I rewrote it just so it's all in the same line. I should do a different color. There we go. All right, so same line across, because if you did a line, it's like tough to really say, oh, there's my reactant, there's my product. Hopefully I don't have any typos. All right, next thing I would do is put a line down the middle between the reactant and my product side. So line down the middle between the reactant and the product side. And then I could compare some values and just manipulate coefficients here. Do you have any volunteers that want to teach the class, or pass them? I'll pass the mouse over to you. Guide me the last 2 questions. Philip, haven't talked to you in forever, maybe ever. Do you want to talk, Phil?
Hi.
Hey, Philip, how are you doing today?
Good. How are you?
Not too bad. I think I did talk to you before because your mic is like great quality. Maybe. All right, Phil. Thanks for asking. I'm doing fine. Do you want to teach your class, or do you want to guide me like Bellman did, or?
I'll have you help me with it.
All right. How many ALs are on the reactant side?
2.
2. How many sulfurs on the reactant side?
12.
So sulfur. So this time, analyzing the, just break this on in. So that, change the color. So that 3 outside the parentheses gets distributed to everything inside of the parentheses. So this sulfur up here only has 3 to the left. So there's only 3 because it's getting distributed to the left. So sulfur, there is 3. Next up is oxygen. How many O's do I have on the reactant side?
14.
All right, so 4 times 3 is 12 plus 2, 14. 14. How about calcium?
1.
1. And the last element is hydrogen. How many H's?
2.
2. So that was tricky. Let's just make sure a couple things. He distributed the values here, so that worked out. Trying to figure out a better color system. He distributed that to everything inside the parentheses for that one. So again, that 2 is distributed everything inside the parentheses. All right, let's check out the product side. I make ALs, keep it in this exact same order.
1,
1, sulfur,
1,
oxygen,
8,
so 3 transferred over to everything in the parentheses. So 3 plus 4, 7. One off there, unless I made a mistake. All right, next up is CA. How many?
1,
1. And H. How many H's?
3,
3. Santina, what was 3? Oh, I'll have to go back to that in a second. Question number 3, I'll go back. I don't really know off the top of my head. Unless someone knows what answer for number 3 was, you could give it to them. All right, so here we go. Step 1 would be balance the metals. Balance the metals. Do we have any metals here?
aluminum,
Aluminum. Anything else?
I don't think so.
Should be one more.
Calcium,
Calcium. Aluminum, calcium, both metals. Which element do you want to balance?
aluminum,
All right, how are we going to balance aluminum?
multiply by 2 on the product side.
Good. So we have 2 on the left. I want 2 on the right. So I have to add a coefficient of 2, which is correct, in front of AlOH3. That's going to change aluminum to 2. But it's also going to change my oxygen and my hydrogen as well. So oxygen, oh, this should be 2. There's, distribute this as well. That 3 goes to everything inside the parentheses. So 3 times 2 is 6 for oxygen, plus your 4. So oxygen is now going to be equal to 10. And hydrogen is now changed. 2 times 3 is going to give us 6. All right. Metals are balanced. Good. My metals are Al and Ca. Next step would be balance my nonmetals besides H and O. So that's got to be sulfur. Balance the sulfur. How you can do that? I have 3 on the left. I need 3 on the right.
Multiply by 3.
Yeah, put a coefficient of 3. I forgot to put a dash there. Put a coefficient of 3 in front of CaSO4. It changes calcium to 3. Changes my sulfur to 3. And it changes my oxygen to 3 times 4, which is 12. Plus 12 plus oxygen, we have 2 times 3 is 6. So that's going to give us 18 oxygen. It's a little messy here with my mouse. All right, step 1, balance my metals. Are the metals balanced?
Yeah.
Aluminum's balanced. Calcium's not balanced. I have 3 on the right. I need 3 on the left. How am I going to balance my calcium?
Multiply by 3.
Put a coefficient of 3 in front of CaOH2. So if I put a coefficient of 3 there, it's going to change calcium to 3. That's balanced now. My oxygen is going to be a different number now, so I have to change that. So 2 times 3, that 2 is carried in, times your 3 is 6, plus, don't forget this guy, your 12. So oxygen is now 18. And the last thing is hydrogen. How many H's? How many H's do we have there?
We need a coefficient of 3.
Just check out this last H right here. How many H's are in that one?
2.
That 2 carries on over. 2 times your coefficient of 3. So that 2 carries on. That's definitely 2 times your 3 as well. So that
Six.
should be, yeah, so 6. What do you want to do next?
Put a coefficient of 1.
Okay. Anything else?
No.
Thanks, Philip. So we have aluminum's balanced on out. We have sulfurs both at 3. Oxygens both have 18. Calciums both have 3. And H's both have 6. So yes, that works out for that. So coefficients are 1, 3, 2, 3. Jumila, you asked if you could. I did it, but I wrote OH. I got the same answer. Yes, you could keep the polyatomic ions together. I don't usually teach it like that, but you can. There's a way to do that. So if it works out for you that way, Jumila, no, one of the videos talked about that. So you could do that too. All right, so coefficients are 1, 3, 2, 3. 1, 3, 2, 3. Any questions before I clear out this board? Okay, so coefficients are 1, 3, 2, 3. 1, 3, 2, 3. 1, 3, 2, 3. The sum, what's the sum of coefficients? So add them all together. 3 and 3, 6. Plus 2, 7, 8, 9. Best answer again would be choice B. Thanks again for your help, Philip. So that one is choice B. Clear out the scale. Let's figure out where we're at. One more to go. Someone had a question. Number 3. 3 was. I don't remember. 3. Santino, you could balance this out again. I can't remember off the top of my head. Maybe someone could help me out here. Santino wants to know what question number 3 answer was. I think it was C. Maybe it was B. I can help you at the end of class if you want to go through that together. All right, last question here. It says, given the unbalanced equation, when the equation is correctly balanced using the smallest number of coefficients, what is the coefficient of CO? So Phil, you got like one of the tougher questions, so thank you for your help. One last question, then you guys are off on your way. Any volunteers for this last one? Anybody? Could have went today, could have went yesterday, I don't care. No, you don't have to turn this in. Warm-ups, examples, you don't have to turn in. Exit passes, though, you do. All right, throw another dart out there, see what happens. Ryan. Hi, Ryan. How are you today?
I'm good.
You ready to help me?
Yeah.
Do you want me to pass over the mouse to you so you can teach the class?
No, you can do it.
All right, Ryan. Thanks for helping me out here. All right, so here we go. Where are my reactants?
What?
Are reactants to the left or the right of the equation? Reactants.
I forgot.
Reactants are over here. These are the things reacting. The products are going to be over here. So in a chemical reactions, the reactants are equal to the products. All right, let's try it out. So we have Fe. How many Fe's are in the reactant?
2.
Oxygen
4.
and carbon.
1.
1. Keep them in the exact same order for the product side. How many Fe's in the product side?
1.
Oxygen
2.
and carbon.
1.
Okay. Step 1, balance the metals. Do we have any metals?
Fe.
Definitely Fe. So we're going to balance Fe first. Let's start there. How are you going to balance Fe?
Put a 2 on the right side.
2 on the right side. Put coefficient 2 there. Changes my Fe to 2. Good. Step 2 would be balance my nonmetals except for H and O. What do you want to balance now?
The oxygen.
Yeah, you can't balance the C. It's already balanced.
Uh,
Wait, I made a mistake here. That's why. Oxygen. Oh, did I? No, I didn't make a mistake. Did I? No. So we got balance CO. Let's figure out a way how to balance CO. How you can balance CO?
put a 2 on the right
Two on
side.
the 2 on the product side. Coefficient 2 there. Changes carbon to 2. Changes oxygen to 4. Now what do you want to do?
Hmm. Uh, can we put
Carbon's not balanced. You have a 2 on the right. We need
put a 2 on the left side?
2 on the left. Changes carbon to 2, but it also changes oxygen. Carbon to 2. Oxygen to 5, right? 2, 3 plus your 2 is 5. All right. Now what are you thinking?
Thinking balance.
So I have 5 oxygen on the left. I have 4 on the right. So in this situation, we know we're going to have to get to some sort of even number here. So now I would try, let's see, I would try to put maybe a coefficient of 2 out in front of here, see what happens. Let's see what happens here. If we have, now we have 4 FEs and we have 6. See if we get any closer. Now I have 6 oxygen plus 1, which didn't help me out at all for getting this into even number. 6 plus 1, 7. Didn't work out there. So it's a lot of trial and error. If you keep manipulating these numbers, you'll probably get there. Well, let's go back to FE again. We got balanced FE again, the situation. Now if I put a 4 out in front, so that's going to change it to 4. Now we have to balance oxygen again, still stuck. 8 O's. Oh, 6. Oh, thank you. Thank you, Jumi La. There's 8 O's on left. 8. So 2 times 3, 6 plus a 2. That would give us 8. Let's see if that helps us out. Now we have to get 8 on the right. How do we get 8 oxygens on the right?
Put a 4.
All right, let's try a 4 there. Let's change that to a 4. This is a tricky one. So 4 changes carbon to 4, changes oxygen to 8. Getting closer. 4, 8, 4. So now we need 4 carbons on the left.
So I put a 4 right there.
4 there. So we have now I have 4 carbons. How many oxygen on the left?
8, 10.
10. Oof. Let's see how long some of these could take. Metals are balanced. Still oxygen's messing with us.
Put a 5 on the right side.
Try a 5. Let's see what happens there with a 5. So now we have 5 carbons and 10 oxygen. Next.
5 on the left for a carbon.
5. So 5 carbons. And oxygen.
11.
11. So you can see here how long some of these could take. Next.
Put a
All right, I'm going to rework this one out. This whole one I'm going to work out and put on a separate piece of paper, and I'm going to upload it to the page. Maybe you got the coefficients, maybe not. I'm not going to stop. I'm not going to go through this anymore for this question. I will put the coefficients up there so you can see the work. You'll see hopefully how I cross the ones out as I progressed. And hopefully, did anybody get an answer for this one? Throw it in the chat privately as you went through it. All right, a couple of us got some answers. So maybe you did get an answer. Obviously, this took a little bit longer to do. I'm going to stop class there today. I'm going to put this on the classroom page. I'm going to upload a picture with the work and the coefficients. Hopefully you could try it. Yeah, a couple of you guys did get the right answers. So thank you for doing that. And that note, that's going to be it. You can work on the exit pass now. Just a little heads up. Next class, I'm going to give you some time at the beginning of class. Instead of doing a warm-up tomorrow on reviewing, I'm going to give you the 10 minutes or so to go through these questions on the exit pass on balancing equations. I'll put you in breakout rooms by yourself, and then you could answer or ask me any questions that you may have on the exit pass too. You do not have to submit this exercise. This does not be submitted. We will, I do not grade the examples because I typically go through most of them together. On that note, that's it, guys, for today. Again, I'll post this up there. You can work on the exit pass, but I'll give you time tomorrow in class to do it as well. Have a great day. Stay safe, and see you later, guys. Bye. Bye, Kai. Bye, John. Have a great day, guys.
Bye, Mr. Brown.
See you later. Have a good one. Bye, Kim. Have a good day.